Algebra 2 Winter Break Packet 2010-2011. Here we have at the left my pool playing buddy and math department chairman, Mr. Becksmith, the author of the packet, and on the right, myself, G-Dog Sr., wearing my G-Dog t-shirt. Number 1 is a domain and range problem. Remember that domain is all the x values of a relation and that range is all the y values of a relation. What is the meaning of this solid dot for the domain? The domain or x values are greater than or equal to it since it includes the point itself being solid. And what about this open circle on the right side? The x values are going to be less than it since the open circle is a hole that doesn't include that point. One way to write your answer is in interval notation. Domain colon x is greater than or equal to its lowest value and is less than the highest value. Then you'll do a similar process to identify the range of the relation, except that the limits of the range are going to be the highest and lowest points on the graph represented by here by the blue line segments. Here's problem 2. The shape of each arch supporting the exchange house can be modeled by h of x equals negative 0.025x squared plus 2x, where h of x represents the height of the arch and x represents the horizontal distance from one end of the base in meters. What is the reasonable domain for the situation? In October's benchmark test, this is a problem that even with multiple choices available, students did terribly. With this problem and others in this video, please don't go straight through to the end and write down the answer. As I proceed, try to work ahead of where I am a little at a time and only roll forward to check your work or get a hint if you get absolutely stuck. Two key words here are reasonable domain. With this negative quadratic leading coefficient, we'll have an arch that looks something like this. The y-intercept is 0, so we'll have x is greater than or equal to 0. But without a graphing calculator, we'll need to try to factor the equation to solve for 0. Let's set negative 0.025x squared plus 2x equal to 0. I like to make the quadratic coefficient a positive number, so by multiplying every term by negative 1, we have 0 equals 0.025x squared minus 2x. Now we can factor, and we have 0 equals x times quantity, 0.025x minus 2. We separate the factors into two separate equations equal to 0. We have, of course, x equals 0, but then we already figured that one out. Then to get the other end of the arch, we have 0 equals 0.025x minus 2. We solve for x by first adding 2 to both sides of the equation. Negative 2 plus 2 cancel on the right side, so now we have 2 equals 0.025x. Next, we divide both sides by 0.025. 0.025 over 0.025 cancel on the right side, so we're left with x equals 80. So we use that number to finish out our reasonable domain, less than or equal to 80 meters. Now that's the reasonable domain. While the domain of the function is all real numbers, a reasonable or restricted domain will always be a part of it with minimum value and a maximum value. This is the real world, limited domain and range. Here's problem 3. The area A of a parallelogram is 64x to the 9th y to the 6th square feet. The height h of the parallelogram is 16x cubed y squared feet. The area of the parallelogram can be found by using the formula A equals BH, or area equals base times height. Which of the following best represents the length of this parallelogram's base, B? We can start by labeling a parallelogram with its height. We don't know yet what B is, but we know that B times the height, 16x cubed y squared, equals the area of 64x to the 9th y to the 6th. To find the expression for B, we need to divide both sides of the equation by 16x cubed y squared. We have cancellation on the left side of the equation. The base equals the area divided by the height on the right side of the equation. I've done the hard part for you. We'll need you to finish the rest. You can either solve it by expanding the numerator and denominator and canceling out all the x's over x's you can, or by using the rule of the quotient of powers, which is that x to the a divided by x to the b equals x to the a minus b. Finish it out. You can do it. For this one, problem 4, we have which expression best represents the simplification of 3 times m to the negative 2 n to the 4th times negative 4m to the 6th n to the negative 7th. We'll leave you to do this one, but we'll review a couple of the rules of exponents you can use here. First, we'll have the product of powers, x to the a times x to the b equals x to the a plus b. And then there's the rule of negative powers. 1 over x to the negative a equals x to the a, and also that x to the negative a equals 1 over x to the a. Now we have this problem, number 5. What is the inverse of the function f of x equals 1/3 x plus 4? The first thing we'll do is change the function into y and x form, and that's y equals 1/3 x plus 4. Then we'll rewrite the equation and swap out the locations of x and y, so we have x equals 1/3 y plus 4. Using the symmetric property of equality, we turn the equation around so we have the y we want to solve for on the left side. Then we subtract 4 from both sides of the equation. 4 minus 4 cancel. We have 1/3 y equals x minus 4. Let's bring the equation up to the right on top to give us some room to work with. Now we can multiply everything by 3. 3 over 3 cancel. So we have y equals 3x minus 12. And we can rewrite the equation in inverse function notation. F to the negative 1 of x equals 3x minus 12. And while I know that at home you may not have a graphing calculator, this is what the two equations look like entered in the y equals function editor. And this is what they look like graphed in a standard TI-84 Plus window. And here you see that they have symmetry about the line y equals x, which is traced in red. For number 6, another inverse function problem, you'll need to work this one by yourself. If you have a question about this one, private message me or make a comment and I'll try to give you some help. Just look at how I worked out problem number 5 first. Here we have problem number 7. The graph shows the path of a jet of water. The equation corresponding to this graph is y equals a times quantity x minus h squared plus k. What are a, h, and k? Again, as on problem 2, you will learn the most if you try to do as much as you can and advance the lesson little by little to see if you can work ahead, only playing on to check your work or if you get stuck. Pause it now and try it. It helps us to know what kind of equation we're looking at, and this is a function in vertex form. This value k is the distance from the x-axis to the vertex, and it looks like it's 6. The next thing we'll find is h. Where is the axis of symmetry of the parabola? It's here where x equals 4, so h equals 4. Now, since we have some points we can identify, we use our vertex form of the equation to solve for a. I would like to use the y-intercept 0, -2, since that will help the math to be easier. Here's our equation in red that we're going to use, y equals a times quantity x minus h squared plus k. And here are the arrows directing traffic from our known values to our equation. Here are the values filled in. On this equation I did two things. I subtracted 6 from both sides of the equation and I squared -4 inside parentheses, so we have -8 equals 16a. The next step is to divide both sides of the equation by 16. 16 over 16 cancel on the right side, so a is equal to -1/2 or -0.5. So rewriting the equation, we have y equals -0.5 times quantity x minus 4 squared plus 6. And that is the equation in vertex form after we were able to find a, h, and k. And here is that equation graphed with the equation in the function editor and the window adjusted just like the original graph, and it shows that we got it exactly right. Problem 8. 3 functions below model paths for 3 different angles of the water. There are 3 equations given for us to choose between to answer the questions below. This problem has equations in vertex form, y equals a times quantity x minus h squared plus k. Which number tells us how high or low the graph goes? Is it a, h, or k? Go back to problem number 7 and look at the k of 6. What would have happened in that equation if the k was more or less than 6? That will help you answer this question. Then consider the same thing for the next 2 questions about sending the water farthest or than the widest path. I cannot give you more information than that without just telling you the answers, which would defeat the purpose of this assignment. But here's a graph of these 3 equations. Do some thinking and research. The first question should be quite easy. The other 2 you can answer, but maybe not as easily. We'll really be looking for your explanation of your reasoning on this problem. Problem 9, completing the square. Samantha needs to solve the equation x squared minus 12x equals 40. What must she do to each side of the equation to complete the square? The key thing to this one is knowing how to get enough numbers to fill out a perfect square. With algebra tiles, this is what x squared minus 12x looks like, with the -12x's just being separated into 2 portions in our square. The question we need to answer is, how many of the little square yellow positive 1 tiles do we need to fill in to complete? When you find that out, add that number to both sides of the equation. Then, take the square root of both sides of the equation. Then finish solving for x. As a hint, you will finish solving for x by adding 6 to both sides of the equation. Problem 10. The length of a rectangle is 2 feet more than its width. Find the dimensions of the rectangle if its area is 63 square feet. I like to start problems whenever I can with a picture, in this case the picture of a rectangle. What do we know about this rectangle? We know that its area is 63 square feet. We also know that the area of a rectangle equals its length times its width, so we can rewrite the equation as LW equals 63 square feet. We then take this bit of information at the beginning, that the length is 2 feet more than the width, so we can call the smallest number x for the width. And since the length is 2 feet longer, we can represent that length as x plus 2. Then we can write our equation as x times quantity x plus 2 equals 63. Using the distributive property of algebra, we have x squared plus 2x equals 63. From here, you can solve by completing the square, or if you subtract 63 from both sides of the equation, you can solve by graphing, factoring, or the quadratic formula, which I leave to the viewer. I've done most of the thinking work for you on this one. Number 11. The graph of a quadratic equation of the form y equals ax squared plus bx plus c is shown below. Is the discriminant b squared minus 4ac positive, negative, or 0? If this was an attempt at solving a quadratic equation by graphing, how many real solutions would there be? I hope you can see that there are no real solutions. How do we know that? The graph does not have any x-intercepts or any place that the graph touches the x-axis. Here is our quadratic formula in the lower right. What is the only way in the quadratic formula that there can be no real solutions? Is this number under the radical, the discriminant, going to have to be a positive, negative, or 0? Answer that, and you've answered the question in this problem. Problem 12. Use the quadratic formula to solve the equation 5x squared minus 2x plus 4 equals 0. And here in blue is the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac, all that over 2a. We identify a, b, and c from the equation. A equals 5, b equals negative 2, and c equals 4. I like to make a quadratic formula with parentheses to fill in with a, b, and c values. And here it is with a, b, and c filled in. The first thing to look at is the value of the discriminant under the square root sign, and that simplifies to 4 minus 80, or negative 76. I'll leave it to the viewer to continue solving from here. Are there real solutions? If not, what are the imaginary or complex number solutions? Problem 13. Determine the solutions to the quadratic equation based on the data in the table below. In looking for solutions, we look for y values of 0 here in this column on the right side. While we don't see any zeros in the y values, we know that they have to be here between 6 and negative 2 and between negative 2 and 6 because the values go from positive to negative between x equals negative 3 and x equals negative 1, and from negative to positive between x equals negative 1 and x equals positive 1. We can insert those y equals 0 numbers at x equals negative 2 and at x equals 0 and see if they work out to a quadratic equation. If so, you've determined the solutions to the equation. And we'll just leave it there, hoping you come back with some thoughtful answers to this problem after you work on it. Problem 14. What is the solution set for the equation 4 times quantity 3x minus 2 squared equals 36? We could solve this by graphing, completing the square, or by the quadratic formula, or maybe even by factoring. Let's divide both sides of the equation by 4. 4 over 4 cancel on the left side. We now have quantity 3x minus 2 squared equals 9. Now we can take the square root of both sides of the equation. And now I'll leave it to the viewer to follow through and complete the problem. Problem 15. Graph the equation y equals 2 times the square root of quantity x minus 2. We can start by setting up a table of values, starting with an input value of 0. That gives us 0 minus 2 under the radical or square root sign. And what is the square root of a -2 or any negative number? It's not real, so we cannot graph it on an xy coordinate plane. If we enter it in our calculator, we get an error message. So we have to skip up to 2 to start getting real numbers as answers, as input values. That would give us 2 times 0, or 0 as an output for an input of x equals 2. We could then mark that first point on our graph. Then we can enter other points with values, for instance, inputs of 3, 4, and 5 to better graph the equation. I'll leave it to the viewer to calculate the output values, plot the points, and trace the curve. Problem 16. Write a square root function / equation for the table below. This one puzzled me for a while because I was not sure how to do it, with or without a calculator. I finally figured out that I could use my knowledge that the square root function is the inverse of a quadratic function. If we switch the x and y values in a table, we should be able to find the quadratic function and then find the inverse of that quadratic function to get our square root function. Since it took me a little while to figure out how to do this one, I'm going to work it all out. And since I've already told you how I'm going to do it, please pause the video from here and try to work it out yourself, then play on to see my solution. To find the quadratic function, on the table on the left, we see that on the left side, the numbers go up one at a time, 3 of them in a row, from 0 to 1, 1 to 2. And that means that we probably have enough information to find the quadratic function. Now on the y or right side, we have first differences of 1/3 and then 1. And then we can go on to get our second difference, which is 2/3. In finding quadratic functions, a is the second difference divided by 2, and 2/3 divided by 2 is 1/3. So the first part of our quadratic function is f to the -1 of x equals 1/3 x squared. And then we know that a plus b equals the first difference, where x goes up from 0 to 1, and that is 1/3. So that gives us 1/3 plus b equals 1/3. We solve for b by subtracting 1/3 from both sides of the equation, and b equals 0. And that means that there is no x term or linear term in this function. And finally we get the c, which is simply our y-intercept of 2/3. Now we're going to write the function as y equals 1/3 x squared plus 2/3. Then we can change it to the inverse of that by swapping the x and the y, which should be x equals 1/3 y squared plus 2/3. Now I'm going to take that equation up to the top on the right side of the page to give us some room to work below. Now with that equation, I'm going to switch sides and use the symmetric property of equality, so my y is now on the left side. Now we'll start to solve for y by subtracting 2/3 from both sides of the equation. 2/3 minus 2/3 cancel on the left side. We bring down what's left. 1/3 y squared equals x minus 2/3. We multiply the entire equation by 3 to get rid of the 1/3 on the left side. That leaves us with y squared equals 3x minus 2. And taking the square root of both sides, we have y equals the square root of quantity 3x minus 2. Without a calculator, we can plug in these numbers from the table and see that it's a correct equation. And this equation, y equals the square root of quantity 3x minus 2, now boxed in, is my final answer. I'm hoping that Mr. Becksmith might be able to show me an easier way to do this one. Problem 17. State the domain and range of the function f of x equals 3 plus the square root of quantity x minus 2. I'll leave this one, what I think is a pretty easy problem, to the viewer, except to point out that it's similar to the same case in problem 15. The domain has to start at 2 because anything less than 2 will result in a non-real number requiring the square root of a negative number. Good luck on this one, and let me know if you have questions. Problem 18. Find the value of x if the perimeter of a triangular dog pen is 25 meters. Since perimeter is the distance around the outside of something, we just need to set up the equation 12 plus 10 plus the square root of quantity x plus 1 equals 25. This seems quite an easy problem, and I'll let the viewer take it from here. This has been Algebra 2 Winter Break Packet 2010-2011. Thanks for viewing.